Okay, so 5.5 is all going to be about multiplication of polynomials. And so we saw last time that there's a couple different classifications of polynomials. There was monomials, which only had one term. There was binomials, which had two terms. Trinomials had three terms. And then after that, we just classify them all as polynomials. And so we're going to learn different ways to approach multiplying these based on what kind of a polynomial we are facing. So the first type is going to be a monomial times a monomial. So what this means is we have one term times one term. We're going to do two examples of this. You can already see the examples up here. We have 7x to the third times 6x to the fifth. We have one term times one term. Monomial times monomial. When you're doing monomials times monomials, what we're going to do is we multiply the coefficients, or the number parts, the numerical parts, and then we multiply the variables if we are able to. If they're not the same variable, we can't really do anything to change them, but these are the same variable, and so this is where we have to reflect back to our exponent rules that we learned in 5.1. When we have the same base, and we are multiplying them together, then we're going to end up using our product rule to combine our exponents. So what we're going to do is we take 7 times 6, and we're going to take x to the third times x to the fifth. This is our product rule. Our product rule from 5.1 states that whenever we have the same bases, what do we do to our exponents? Yeah, we add them. So 7 times 6 is 42, and if we are adding our exponents, 3 plus 5 is 8. Monomial times a monomial, you multiply the number parts together, you multiply the variable parts together if you were so able to. That's it. We are not solving in this section. We're not trying to figure out what x is. We don't set them equal to anything. We're just multiplying. So the same thing on the next one. I'm going to take 4 times a negative 9. And we're going to take b squared times b to the 7th. Now, I won't always write all these little steps out. I'm doing it right here because they're going to get a little bit harder, and I won't write every single little step out. Remember, when we have a positive number times a negative number, you will end up with a negative. So 4 times 9 is 36. Again, we're going to use our product rule on our variables because they do have the same base. This time we're taking 2 plus 7, which will give us 9. So all the rules we learned in 5.1 on how to combine our exponents, they're still in play. We're not going to forget them and leave them. Negative exponents are still at play, although I don't think any of our examples deal with negative exponents today, but they are still there. So monomial times monomial is pretty straightforward. Are there any questions, though? All right, let me pull up this back piece if I can. So what if we take a polynomial by a monomial? That's when we're going to use our distributive property. We talk about a lot of different properties in Math 20 in 1.10. And I tell my students in 1.10, these are all very good properties. They're all accurate. They're all great for math. But the one you need to remember is your distributive property. Because the distributive property is the one that you actually utilize the most in mathematics in terms of using it to manipulate around problems. So your distributive property is where you're going to have a monomial out front, or you could have it in the back, but generally I would rewrite it to have it out in front. And then what we're going to do is you take your monomial times everything that's inside of your parenthesis. So what this is implying is that what's inside your parenthesis, that B and that C, can't be combined any further. And so there's nothing to do inside the parentheses. And so what we do is we multiply everything from the outside and bring it in. And this works whether or not your polynomial has 2 terms and is a binomial, if it has 3 terms and it's a trinomial, if it has 18 terms, it doesn't matter. You can use your distributive property and carry that A inside as many times as you need to. Oops. And we will do 2 examples, but it looks like I forgot to write the rest of that example. So hold on. 3xy. Because this term is second back here. I got distracted on that one. So for A, we have negative 3n out front, and then inside of our parentheses, we have a trinomial. We have 4n squared minus 2n minus 1. So we're not trying to solve for n. We don't have to factor. We don't have to do any of that. What we're trying to do is we're trying to get rid of the parentheses, and the only way to do that is to distribute that negative 3n inside to each of the terms. So I'm going to be taking negative 3n times 4n squared. Now, I usually do this in my head. For this first one, I'm going to write it out side by side so you see exactly what steps I'm doing, so that if you go back and reference this video later, you know exactly what I did. I'm going to take negative 3n times the 4n squared. That's what I'm going to do. Then I'm going to take the negative 3n times the negative 2n. Then I take the negative 3n times the negative 1. Now, I don't usually ever write out this long version here, but I do always draw these arrows as I work through the process because that helps me to know, 1, what have I already distributed to, and then also make sure I don't accidentally leave anything off. Because if you're dealing with a long polynomial inside, it's easy to accidentally forget if you've carried it into everything. So when we're doing this, once we've distributed, if you look, we just have a whole bunch of monomials times monomials. It's exactly what we did up here. Negative 3 times 4 is a negative 12. N times n squared would give me n to the third. Then I move on to my next term. I have a negative 3 times a negative 2. Negative and negative becomes a positive. N times n would give me an n squared. And again, negative and negative would give me positive. 3 times 1 is just 3. So you take what's out front and you make sure and distribute it to everything inside. Questions? For B, our monomial is at the back. And that's okay. If you don't like your monomial at the back, you can simply rewrite the problem to where it would say 3xy times the 4x squared minus 12xy plus 9y squared. If this makes you more comfortable, you can rewrite it like that. Totally okay. Honestly, that's usually what I would do. If you are comfortable with it being on the back end, you can distribute by bringing it in still the exact same way. Your arrows just go to the left instead of the right. You're not changing anything just because it's written in a different order. We're still going to multiply or distribute the exact same way. I think I am going to come over here to this side, though, just so my arrows don't hit the answer above, where I'm going to take 3xy times 4x squared. So 3 times 4 is 12. X times x squared would give me x to the third. And now there is no y term inside of my parenthesis, and that's okay. I still have this y term for my monomial outside, so I just write that right there. Not a problem. Then I'm going to distribute the 3xy to the negative 12xy. 3 times a negative 12 is a negative 36. X times x, x squared. Y times y is y squared. One more, because we do have a trinomial inside. We have 3 times 9 It's 27. X times, there's no x inside, so I'll just have an x. Y times y squared will give me y to the third. I cannot combine these any further. And usually that's something I would look for first before I would distribute, is making sure I couldn't combine anything. But I cannot combine these. And in general, we write these in what is known as a descending order, meaning that our x term, whatever is the highest variable on your x term, would come first, then the next x term, then the next x term. It's easiest to see up here with this n, because there's only one variable at play. And so our first term has n to the third, our second term has n to the second, our third term has n. This is descending order. And it's the best rule of thumb to always write your polynomials in descending order, because when we do start solving these, if we have them written in that format, they're ready for us to factor them and to solve them. If we don't have them written in that format, then we have to do that. And so if you just get in the habit of always writing your polynomials in that form, it does simplify your life later on. So any questions on how we use the distributive property to multiply a monomial by a polynomial? So we did these. Now the big one. Foiling. Binomial times a binomial. You will do this over and over and over again. And if you're not good at foiling yet, now is the time. So foiling is simply a method, really, to distribute binomial by binomial. That's really what we're doing. We're distributing each of the parts in the first binomial to each of the parts in the second binomial. But the FOIL method helps us to remember it, and it helps us to keep track of what we've done. So FOIL stands for first, outer, inner, last. And if you do the arrows, which you totally don't have to, but I always do the arrows when I do them, it kind of looks like a face, where the top arrows become your eyebrows, and you've got your nose and your mouth. That's what I see. So when you take first, what you're going to do is you're going to take the first term in the first parenthesis times the first term in the second parenthesis. So that's your first. Then you take your outer, so the outside two most terms, and you're going to multiply them together. Then you take your inner terms, and you multiply them together. And then you take the last term in each of your set of parentheses. So first, outer, inner, last. And that's what's written over here. These are our first terms, our outer terms, our inner terms, and our last. Foiling is like the opposite of factoring. And we will do lots of factoring later on. So first, outer, inner, last. Binomial by binomial. Just sliding it up. First, outer, inner, last. So typically, when we have our binomials, they will actually look like B, where we have our x term first within our binomial. But in our first example, our x term is actually written second. This is mostly to do with the fact that if you look at our x's, they're negative. And so it looks a little bit nicer to have the negative in between our number and our variable term than have a negative and then plus a positive. It doesn't really change anything at all in how it presents. You're still going to FOIL the same way. So FOIL is first, so I'm going to take my first terms and multiply them together. 4 times 6 is 24. Then I take my outer terms. That'll be 4 times a negative 5x, which gives me a negative 20x. Then you do your inner terms. A negative 2x and a positive 6 will give me a negative 12x. And then we do our last terms. Negative 2x and a negative 5x will give me a positive, because negative times negative is positive. 2 times 5 is 10. X times x is x squared. Now this is where I'm going to go ahead and reorder, because I notice I have my number, my constant first, then my x term, and then my x squared term. So I'm going to write my x squared term first, so I can write it in descending order. I have two x terms, so I can simplify and combine these. I have a negative 20x and a negative 12x. That'll give me a negative 32x. And then I have my plus 24. Will Pearson count you wrong if you don't reorder it? No, it won't. You can leave it as 24 minus 32x plus 10x squared. Best practice, though, is to get in the habit of the rewriting. Because later on, if we had to solve this, it's set up for us to solve it. The other way, we'd have to move it around. First, outer, inner, last. Let's do B. Same thing. First is 2x times x, which is 2x squared. Outer, 2x times 4, so positive 8x. Inner, negative 3 times x, negative 3x. Last is a negative times a positive, so I will have a negative, and 3 times 4 is 12. Again, I have these two middle terms, these two x terms that I can combine, so I'm going to do that. 8 minus 3 will give me 5x. While you're going to use all of these different methods to do your multiplication of your polynomials, the FOIL method is definitely the most integral. You will do it over and over again as we progress through this class and as you move on into college algebra. Are there any questions about it before we start looking at some special FOILs? This is a special FOIL. The product of difference of squares. I usually just shorten that to difference of squares. Difference of squares, when we're going from the factored form into the non-factored form, isn't all that bit exciting. But when we have to go from this form into the factored form, if you know what the difference of squares looks like, it simplifies your life a ton. So, difference of squares, if you notice here, we have a minus b and a plus b inside of our parentheses. So, we have the same first term and we have the same last term inside of our parentheses. The only thing that changes is the sign in between. And so what ends up happening is, and I'll show you the long version of this. It's not really long or anything, but I'll show you what happens. If I were to take a plus b times a minus b, so I do my FOIL the regular old way. First would give me a squared. Outer would give me a negative ab. Inner would give me a positive ab. And last would give me a negative b squared. Look what happens to our middle term. It falls away. That will always happen with difference of squares, which is why we can see it as just a squared minus b squared. So like I said, when we go from the factored form to this form, honestly, I usually still just FOIL like the regular old way. That's usually what I do. If you see it, though, and you're like, oh, this is difference of squares, I just need to square the first term and square the second term and put a minus in between, you can totally do that. In my handwritten notes, that's how I approach these problems. I look at them and I say, okay, what is my A, what is my B? I square both of them and stick a minus in between them. You can do that. That's totally fine. It's actually going to be more imperative and more important for you if you see this later on in the semester, the a squared minus b squared, and you immediately know, oh, that's difference of squares, that looks like this. So going from here to here is going to be a lot more important than memorizing anything to go from here to here, because you really don't have to. You can do your distributive, your FOIL method, your middle terms will fall away, and nothing else changes. So I'll show you both methods on the first one. And you can pick and do whichever method you would like. So for A, we have x plus 5 in our first parenthesis and x minus 5 in our second parenthesis. So if I'm going to memorize the steps for, or like the cheat for a difference of squares, then what I'm going to write down is I'm going to say, okay, what is my A term and what is my B term? Well, your A is going to be whatever that first term is, because notice they're the same in both parentheses. So your A term is your x. And your B term is whatever your second term is in your parentheses, and in this case it's 5. So difference of squares is a squared minus b squared. So that's x squared minus 5 squared is 5 times 5, which is 25. So you can totally approach every difference of squares like this. You identify your A, you identify your B, and basically you plug that into the a squared minus b squared. 99% of the time, that's not how I do it. 99% of the time, I do old-fashioned FOIL. So I would just take, mostly because I'm not stopping to think, is that a difference of squares? I'm just foiling. I see it, and I'm like, okay, I got to FOIL that. So it's x squared minus 5x plus 5x minus 25. These middle two terms go away, giving you x squared minus 25. You get the exact same answer regardless of which method you choose to use. If you just FOIL it, you already are doing FOIL on other problems, so there's not anything extra to memorize. That's fine. If you like just being able to identify your A and B terms and square both of them and stick a minus in between, that's fine. Either one works. For B, I'm just going to FOIL. But I will show you on my handwritten notes the other method. For B, if I'm FOILing, I would do first. 3x times 3x is 9x squared, because 3 times 3 is 9. X times x is x squared. Outer. And here's a nice cheat. If I notice that it is difference of squares, I know that middle term is going to fall away. My outer and my inner don't matter, because I'm going to get a positive 6xy, and then I'm going to get a negative 6xy. So I don't even have to write it. Then I do my last, which will be a negative 2y times a positive 2y, give me a negative 4y squared. Now, obviously, I did all of that in a one-step method. You don't have to do that. You can take as many steps as you like. That's probably how I approach most of my difference of squares, though, because I do less actual work. I write less stuff down. And that's risky, though, if I accidentally drop a negative anywhere. It's always better to show like this much work down here. Here I'm getting a little bit risky. But there's nothing wrong with it. If you like identifying the A's and B's, the first term in each set of parentheses is a 3x. The second term is a 2y. So I'm going to square both of them and then put a minus in between. Again, you can do either method. Are there any questions on the difference of squares? All right, let's look at another special one. Perfect squared binomials. I've had students in the past who memorize these. You do not have to at all. I don't have these memorized. I don't really think it's all that helpful to have them memorized, but they are perfect square binomials. What that means is we have the same binomial, and the whole thing, the a plus b, is squared. So what we do is we write a plus b, and then we write a plus b. And as soon as you write it like this, you can FOIL. That's all I ever do. What you want to make sure you don't do, and this is a form of magic math, and if I haven't used that term yet in this class, magic math is not real math, it is bad math, it is make-believe. Don't do magic math. What I don't want to see is I don't want to see that we have x plus 2 squared, and this is magic math, so don't do it. But I see students do it every year in all my classes. They'll say, oh, well, that's x squared plus 4. That never works. That's you just saying, I'm going to distribute that in, and then what happens is we completely forget that what we're taking is x plus 2 times x plus 2, and when we do our FOIL method, what happens is we forgot that middle term. We forgot this. This will never happen when you do magic math over here. So be careful. This is bad. Don't do it. Don't be tempted to do that. If you see a parenthesis around a binomial and then you have a power on the outside, that's telling you how many times you have to take that whole thing times itself. So write it side by side by side, and then you're going to FOIL. So magic math is bad. So we have it with a plus in there and a minus in there. You don't have to memorize these. What you need to know is when you have a plus b quantity squared, you're going to write a plus b times a plus b. If that said to the third power, you would write a plus b times a plus b times a plus b, and then you'd work through it. I do not expect you to memorize this a squared plus 2ab plus b squared. Scrolling up. There we go. So the first one is 2x minus 3 quantity squared. I am not going to write that that is 4x squared plus 9, because that's magic math. I'm going to take 2x minus 3, and I'm going to write it right next to 2x minus 3. And then I'm going to FOIL. 2x times 2x is 4x. 2x times a negative 3 will give me a negative 6x. Negative 3 times a positive 2x will give me a negative 6x. Negative 3 times negative 3 will give me a positive 9. I can combine these middle terms. That's squared over here, sorry. So that I have 4x squared minus 12x plus 9. Same thing for b. I have 3r plus 2s. And I'm going to take that times 3r plus 2s. On Pearson, whatever variables they give you, those are the variables you need to use. So watch for those, even if you prefer x's and y's. 3r times 3r for our first. 3 times 3 is 9. R times r is r squared. 3r times 2s, that'll give me a 6rs. When you have more than one variable, usually we write the variables in alphabetical order. It's just good habit. R comes before s in the alphabet, so I write r before s down here. Same thing here. When I take 2s times 3r, I'm still going to write it as 6rs. Then 2s times 2s will give me 4s squared. I went off the board, sorry. Again, I can combine these middle terms of 9r squared plus 12rs plus 4s squared. I write my r squared term first because r comes before s in the alphabet, so the r term would be my leading one that I would start with. Any questions? Told you, lots of foiling. Lots and lots of foiling. Okay. This is actually the last little set of notes. We're just going to do some examples after this. There's a whole bunch of notes right there. Polynomial by a polynomial, you're distributing. Now earlier we did a polynomial by a monomial, and we distributed that. Even if we have a binomial times a trinomial or anything else like that, you're still going to use a distributive property. We're just going to distribute everything in every parenthesis to everything and everything else. And I'll show you what I mean. I kind of wish I would have brought another color, but that's okay. I'll use a pencil to show you parts of it. It sounds scary, polynomial by polynomial, but we're just doing the distributive property on a larger scale. That's all we're doing. So since there's not really any more notes, I'm just going to slide this up. So for A, we have a binomial, 3x plus 2, times a trinomial, which is 4x squared minus 5x minus 3. Now, if we only had two terms here in the second one, we would just FOIL and be done. But we have three. And so what we're going to do is we're going to think about it as doing a longer version of the distributive property. I'm going to take the first term in my binomial, the 3x, and I'm going to distribute that to every single term in my second set of parentheses. Then I'm going to distribute the 2 into every single term in my second set of parentheses. I'm doing the distributive property twice. And if I had 3 terms here and 3 terms here, I'd do the distributive property 3 times. I would make sure everything in that first set of parentheses goes to everything in the second set, regardless of how many terms are in there. So the way that I usually do it to keep track of what I've multiplied is I go, my first term I carry on top, my second term I carry on the bottom. So I take 3x times 4x squared. 3 times 4 is 12. X times x squared is x to the third. Then I take 3x times negative 5x. 3 times negative 5 is negative 15. X times x is x squared. 3x times negative 3, that'll give me a negative 9x. And now I have distributed that 3x to everything in that second parenthesis. And I'm done with my 3x. I can ignore it. Now I have a monomial times a trinomial. I'm going to take 2 times 4x squared. 2 times 4 is 8. So I have 8x squared. Then I distribute the 2 to the negative 5x. 2 times negative 5 is negative 10. And then we just have the x. Then I take 2 times the negative 3, which will give me a negative 6. I've distributed everything from my first parentheses to my second parentheses. So now I'm just going to go throughout all of my terms and see if I can combine any. See if I have any like terms. I have a 12x to the third. There's no other x's to the third. So I'm done with that one. I have a negative 15x squared, and I have a positive 8x squared. Negative 15 plus 8 would give me a negative 7x squared. I have a negative 9x and a negative 10x. Combining those, I'd have a negative 19x, and then I have this minus 6 out here. I cannot combine these any further. I'm not trying to solve for x, and I have it written in descending order. Again, Pearson will not count you wrong. Just a good habit. So we just do distribution as many times as we need to. Are there questions on that one? Okay, the next one is a little bit longer looking because we have a polynomial that has 4 terms first and then a binomial. It does not matter if you're starting with something that has 4 terms or if you're starting with something that has 2 terms. I'm going to probably choose, since this one only has 2 terms, to distribute my 2 terms, because here's what's going to happen. If I decide I'm going to distribute this term to both of these, that's totally fine. So I'll do my arcs, and then I'll distribute this one to both terms, and I'll do my arcs. But then for this, I don't have any places left to do arcing, and since I like to use my arcs, I'm going to go the opposite direction. Does that make sense? No. Okay. I'm going to take x squared, and I'm going to distribute it this way. If you want, just rewrite it. I don't have room on this paper. Let me get this one. Rewrite the binomial first, the smaller parenthesis. Then write your longer parenthesis second. If you don't like the arcs, you don't have to use the arcs. Like I said, the arcs for me just help me to know what I've multiplied everything by. Now that I have only 2 terms in this first set of parentheses, I can do my over arcs and my under arcs and keep things organized. That's what I was trying to get at. I would take x squared times 3x to the third, giving me 3x to the fifth. I would take x squared times negative 2x squared, giving me a negative 2x to the fourth. And I keep going with this. I keep distributing my x squared. And once I have carried that x squared to every term in the second parenthesis, I can be done with it. I distributed the x squared to every term. I'm done with that. Now here's where you're going to want to be a little bit careful. We have a minus 5x. I have to distribute that sign as well. So I'm not just distributing 5x times 3x to the third. I'm taking a negative 5x times 3x to the third. So be careful of your signs. Negative 5 times a positive 3 gives me a negative 15. X times x to the third gives me x to the fourth. Let me scroll up. Sorry, guys. Negative 5 times a negative 2 gives me a positive 10. X times x squared is x to the third. Negative 5 times a positive 4 gives me a negative 20. X times x is x squared. And I'll write the other one underneath it. Negative 5 times a positive 6 will give me a negative 30, and then x. Then I do the same thing I did up here, where I look and see, is there anything that I can combine? Are there any like terms? Well, I have one term that has an x to the fifth, so I'll write that first. I have a minus 2x to the fourth, a minus 15x to the fourth. That'll give me a minus 17x to the fourth. I have a 4x to the third and a 10x to the third, giving me 14x to the third. I have a 6x squared and a negative 20x squared. That'll give me a negative 14x squared. And then I have this minus 30x tagged on at the end. You guys can see that. What shines on the wall is not as, like, it's zoomed in more than what's shown on my computer screen, which is obviously different than what's over here on the table, so sorry about that. Okay, questions? They take some room, but really you're just distributing a bunch of times. I do have a C example, and we're not going to do it just based on time. I want to do D, because C is just taking a monomial times a trinomial. So this is no different than what we did earlier, where we take this and distribute it into each term. The only thing that's different is it does contain a fraction. Fractions are going to pop up all semester long, so if you're not comfortable with multiplying, dividing, adding, and subtracting by fractions, my lecture video over 1.3 from beginning algebra or math 20 goes through all of the processes. So I would look at that. But we are going to do D, if I can find D. There's D. The reason why we're going to do D is because we have a binomial times a binomial times a binomial. And this process isn't actually necessarily hard or harder than what we've done, but it is important to pay attention to what the process is. So we have a binomial times a binomial times a binomial. If I only had these first two, what would we do? We'd FOIL. That is exactly what we're going to do. We're going to FOIL, and then we're going to use the processes of distribution that we just did to distribute the second binomial inside. So the first thing we're going to do is we're going to look just at these two, and we're going to FOIL them. So I'm going to take first, outer, inner, last. Combine these two middle terms because they can be simplified further. Nope, that's a 2. And now this one looks almost exactly like B. And we determined, or at least I determined, I don't like having my binomial second, so I'm just going to rewrite it in front. If you're comfortable having it second, that's totally okay. Now I'm ready to do my distribution property. Take x times x squared, giving me x to the third. X times 3x, giving me 3x squared. X times 2. That'll give me 2x. And then I've distributed that x to everything over here. Then I do the same thing with my 3. So I get 3x squared, 9x, and 6. And I combine my like terms. 3x squared and 3x squared will give me a 6x squared. 2x and 9x will give me an 11x. And then I have my plus 6 on the end. So even if you have multiple binomials being multiplied together, you can still do it just using your FOIL and then using the distributive property. Don't let the length of the problem scare you and make you think that you can't do it, because you